Dear friends, for those who do not know this colloquium, PXRF network, and the European Academy of Science and Arts in Salzburg. The brain and the concept behind the main core of this p-XRF is Dr. Michaela Schauer, who is not present today due to academic engagement. So it's replaced by the capable assistant PhD candidate Keelie in Barcelona, Spain. Thank you, Keelie, once more. The Academy has already launched with success the colloquium Arts Meets Science, and also has formed the expert group of members of STEM in Arts and Culture, STEMAC. We promoted interdisciplinarity amongst our 7 classes of different disciplines. The colloquia aim to provide a platform for knowledge exchange, featuring expert presentations from both the natural sciences and the humanities. Recording of the colloquia is available in our EASA, European Academy of Science and Arts website. So I'm glad to see 2 important colleagues this evening, and I would like to start straight away with the first invited speaker, Dr. Mark GOLITKO, who is a professor of anthropology at the University of Notre, a faculty fellow at the Kroc and Kellogg Institutes, a faculty affiliate at the O'Brien International Security Center, and a research associate at the Field Museum of Natural History. His field, laboratory, and museum research has spanned several world regions, including Europe, the Southwestern Pacific, South America, and Mesoamerica. His current field project, the Koros Neolithic Archaeology Project, KNAP, in eastern Hungary, examines settlement growth and aggregation at Middle Neolithic, 5,600 to 5,000 BC, communities on the Great Hungarian Plain. He directs the Notre Archaeological X-ray Laboratory, which houses instrumentation for compositional analysis of archaeological and paleoenvironmental samples. He is the author of books like the Linear Bankeramique LBK Realpolitik from Archaeopress 2015 and Modeling the Past, Archaeology, History and Dynamic Networks 2023, as well as numerous articles and book chapters examining ancient conflict, economy, social networks, human environment dynamics, and archaeological scientific methods. Dear Mark, the online podium is yours.
Okay, thank you. Let me share my screen again. Okay, thanks to the organizers, and thank you for that introduction. Okay, so I just wanted to talk a little bit today about some of the work I've been doing on the north coast of New Guinea, using pXRF as part of a broader research program in which I'm trying to look at how the environment has changed on the north coast of New Guinea, over the last, let's say, 6,000 to 7,000 years roughly. And what people might have been doing both in response to that and how they were dynamic agents of change to the environment. And this is based on field work that took place between about 2011 and 2023. So this is an image of the beautiful north coast of New Guinea. That is the island of New Guinea. So it's the 2nd largest island by land mass in the world, although much more populated than Greenland, I think. So, like most coastal areas in the world, sea level change has been a huge factor in terms of determining what coastal areas look like. And, that's something that we're now experiencing with anthropogenic climate change as well. So one of the questions in my research project was basically how did people over time respond to these radical changes to the coastlines of New Guinea? Obviously going back into the Pleistocene, you have very dramatic sea level drops at times during glacial periods. So what you're seeing here are some of the isobaths down to 120 meters, sort of the modeled lowest sea level during the last glacial maximum. But actually, what I'm mostly looking at is sort of the opposite. So after the end of the Pleistocene, as the Holocene starts, you have the mid-Holocene climactic optimum, or what in Europe is known as the Atlantic climatic phase. So it's a period of actually slightly warmer than average relative to pre-industrial average temperatures. And in coastal areas, that's modeled to sort of increase sea level by up to a meter. Some have suggested 2 meters, but a meter is probably more realistic. In the Pacific, this is a big deal because most of the people in the Pacific live within about a meter of sea level. That's not true on New Guinea necessarily, where the highest population densities are in the interior highlands. But if we're thinking about people living in coastal areas, can have some very dramatic changes to the environments they're living in as a result. If you're in southern New Guinea, you have basically this entire giant plain that connects it to Australia that floods during the early Holocene. On the north coast, I'm working around Aitape, so right about there where that box is. The changes are a little bit more subtle, maybe, in part because basically that entire north coastline is the intersection point between the Australian and Pacific tectonic plates. So it's part of the Pacific Ring of Fire. And that means that basically within 2 kilometers of the modern coastline, you have this dramatic drop off into deep ocean, basically a subduction trench. That means that, as sea level fluctuates, the changes are a little bit different. So when you drop the sea level, you basically get a big cliff. When you raise them, that's basically what I'm looking at in this talk, is what happens. I mean, you have some dramatic differences. So further to the east, you have the Sepik-Ramu Inland Sea that forms during the mid-Holocene, which has been documented by Pamela Swadling and other researchers working in that area. But there hasn't been a whole lot of work done elsewhere on the North Coast. So this mid-Holocene period is interesting because in the Pacific, it's when we first start to get a widespread transport of material culture, obsidian in particular, but also sort of shared styles of stone mortars and pestles. And there's sort of a lot of debate about what the mid-Holocene has to do with later settlement of the remote Pacific in terms of demography, who's actually living in the Pacific and so on, which I'm not going to go into too much detail on today. Okay, so if you focus in on the area around Aitape, why is this area the place I'm working? Part of that's historical accident. I was working at the Field Museum. Field Museum researchers have been working in this part of New Guinea since 1908, or at least visiting it. So I was just sort of the latest in a long line of people doing that. But on another level, it's one of the largest coastal flats currently present on the North Coast. So, it's a good place to look at how these sort of sea level changes, environmental changes actually impact things and how people might respond to this. So this image shows what it looks like today, which is basically you have about 14-ish kilometers of coastal flats from the ocean back to the foothills of the Torricelli Mountains that are sort of fringe the southern edge of it. You have a number of fairly large lagoons that exist there today. So I kind of went into this project based on some previous work that was done by John Terrell, Kevin Pope, and other people that were using satellite imagery and DEMs to try and reconstruct how the coast might have changed as sea levels fluctuated. I'm not going to deal so much with the sea level drop part of this, which happens during the Pleistocene. I do have some data from a place called Paneri Creek where we can see that during the late Pleistocene, there was a large freshwater lake there. So, there's some dramatic changes going on then too, but I'm more interested in what happens as sea levels begin to rise during the early Holocene and ultimately potentially overshoot modern levels. And what Pope and Terrell and others reconstructed was that you would probably get sort of large marine embayments and lagoons that formed here. And this sort of ties into ideas that were first proposed by Chris Gosden and others. Suggested that the mid-Holocene might have been a pretty good time to actually live on the north coast of New Guinea because these lagoons are very resource rich. Fish and other resources suggested that this might have been a period when the north coast of New Guinea first became heavily populated, having been not all that sort of good of a place to live prior to that. But there are a lot of sort of caveats to this because this is a highly tectonically active area. So you can't just take the current elevation, project sea level up a meter, and understand what's happening because the land is actually moving up and down during tectonic events and just as a pattern of gradual uplift from the subduction that's going on here. So really there's some ground truthing that needs to be done to understand like what this environment looked like and how people responded to it. The other problem we have is that basically the mid-Holocene is like an archaeological blank for the north coast of New Guinea with some rare exceptions. By and large, the archaeological record sort of picks up at about 2000, even maybe 1500 years ago, when ceramics first appear in the record. And so one question is it just we're seeing it because there's ceramics suddenly, or are there actually geomorphological reasons why the mid-Holocene record is sort of difficult to identify? Okay, so what was I actually doing there? Well, so first of all, just to give you an idea of what this looks like today, this is looking southwards from a low limestone hill, which they sort of dot the north coast. They're former Miocene islands that have been accreted to the north coast of New Guinea. Those are the Torricelli Mountains in the back that fringe the coastal flats. And I'm just looking over the coastal flats now. What people do there today largely is grow sago palms as their sort of staple carbohydrate, although this open area, there's actually a cattle farm. Okay, and this is the same coastal flats. This is exactly the point I'm looking at in that form photo, but looking the other direction back to where I was standing in the prior photo. That's a place called Mount Mario, which is where I've been working around by and large. This is looking back to the Pacific Ocean. This is what one of these lagoons look like today, and you can see this is a giant fish trap they built here. So these lagoons tend to be places where the highest population densities were present in the sort of pre-colonial era before people got concentrated into towns and into small towns and so on. Okay, I just want to also note that none of this work would have been possible without the help of both New Guinean colleagues from the National Museum of an art gallery and the University of Papua New Guinea. So that's some of my crews from various years on the left there. And also the people of the communities that I work in who, were always generally welcoming. There were occasional incidents, but by and large, they were really interested in what we were doing. And, we tried to do a lot of just talking about what it is we were doing and learning while we were there. All right, so, the field work took place over a number of years. In 2014, we did a lot of archaeological survey and some excavations. In 2016, I went back specifically to do coring and begin to reconstruct what the environment looked like. In 2016, this took the form of a number of cores that were taken around Mount Mario, this low limestone hill I showed you, where we'd also done a lot of archaeology. So we did, I want to say, yeah, 11, 12 cores that year. So because of the logistical challenges of working there, I can't bring in or at least I didn't have the money and ability to bring in like big mechanized coring equipment where I could take these continuous nice cores down. But so what I did was, basically used a bucket auger with 4 meters of extensions on it and a lot of, not my muscle power by and large, New Guinean students who came along. And we just, took out 10 centimeter segments in those years. So initially, I wasn't like optimistic that I'd get nice sort of intact cores. I just wanted to look at like what the sediments looked like, different sides of the hill. But then thought about like what do we do with these? So anyway, 2 cores that I'm going to talk about today. These other cores sort of show us different things, and I'll get back to what that told us in a minute. So in field, basic just recording of sediment, texture, color, and other features. So this is what I'm actually doing while, the cores are taking place usually. Okay, so onto the pXRF part though. Once we get these things back into the lab, they're dried. Well, they're mostly dried in the field, sorted, and we then pick out all the organic matter we can find. did a lot of dating on these cores at the Center for Applied Isotope Studies at University of Georgia, which is one of the best labs for environmental C14 dating in the US. At Notre Dame, then, I used geochemistry on these to begin to understand something about the depositional environment that these sediment cores formed in. So just briefly, I have a Bruker Tracer 5i, for better or for worse. But I find the mud rock calibration on dual calibration on that actually works really well for sediment samples in terms of giving fairly accurate results. When I first did this, I played around a lot with, okay, can we just run the raw sediment blocks? That didn't work so well, actually. There was a lot of heterogeneity in them. Depending on where you analyze them, you got very different results. You had to dry them at first. Like if you do this in the field, I mean, I think you can do it, but the moisture content really makes a huge difference in terms of what results you get. I tried pressing them into pellets and really homogenizing them, and that turned out to be more effort than it was worth, really. So what I finally settled on is you can just take the sediment, finely grind it, and homogenize it. These are fairly fine sediment samples, silt and clay primarily. We do get some that have sand and gravel in them, and that's less useful to use the XRF on. So I don't analyze those, but for the really fine sediment samples, which is what most of these cores look like, I said just weigh them into a sample cup with Perspex thin film on one side and run them that way. So what I'm actually looking at are things that are used in like paleolimnology and other studies of watery environments, let's say. It turns out these largely are, so it works. So there's a ratio of iron titanium to potassium, which is basically the ratio of heavy mineral grains to illite. It's usually used to look at depositional energetics. So any of these can be caused by other things, but these are sort of usually the predominant reasons why these element ratios vary. Manganese to iron, which shows you something about the redox conditions during deposition, so whether it's an oxic or anoxic environment. Calcium to titanium, which generally is sort of shell organic matter or other calcium based materials. Obviously, this also depends on having a sort of a common source of sediment that's being deposited. If you suddenly have something where like a river shifts and you have totally different geology that's being deposited, that's going to cause problems here. Because I'm working on like potentially brackish lagoons, and I'm also looking at sulfur and strontium as a potential indicator of marine input. And then there are non-XRF things like loss on ignition, which is basically just, put this in a furnace and you're burning out all the calcium carbonate and carbonate from the sample. And then chemical biomarkers, which I'm not going to talk about much, but is something that I'm working with a colleague here at Notre Dame on. So these are like leaf wax esters, basically, that give you some information about rainfall amount and whether you're looking at submerged, emergent, or terrestrial vegetation. All right, so one of these cores, core 1, turned out, which is the first one we did, ended up being the most perfect core that we took. The C14 model, this is a Bayesian model in the R Bacon package, and R 8 dates, so, ended up being pretty perfect, like in terms of, this is a nicely deposited core. We're just continuously built up. Everything looks good. As far as the pXRF, so what do these cores actually look like? Well, in their base, they usually have this sort of really fine blue-green clay. That's what you would expect at the bottom of a lagoon or really shallow lake without much depositional energy. But, there's a certain point where you start to get siltier and then, sandier sediments built up on top of that. At the bottom of some of these cores, we actually hit like full-on sand or gravel, which could be either like a remnant beach or a river bank or something like that, or the shore of a lagoon. What we find though is that basically these cores go back to about 6,000 to 7,000 years ago. And every single one of them more or less stopped somewhere around 1,700 years ago. So I'm going to go through these first two cores very quickly, and then I'll talk about the newest core. So what we saw in these initial cores was basically a pattern where around 7,000 years ago, we start with either full marine inundation I'm still not totally convinced of that, or at least a very brackish lagoon that's present. Somewhere after 5,000 BP or so, depositional energy starts to pick up and the lagoons start to infill. I think this is a combination of sea level drop and stabilization and tectonic uplift that's causing more erosion out of the mountains basically behind this, and you're getting more deposition on the coastal flats. Somewhere, and I'll talk more about this in a little while, um, this shifts to basically being meandering river systems that are depositing sediment over the coastal flats. And around 2,500 years ago, and I'll show this in more detail in a minute, those rivers start to incise into their channels as the gradient basically from the mountains to the sea sort of gets to a maximum level. And you basically cease having sediment deposited, which is probably why the archaeological record is so much more visible after about 1,700 years ago or thereabouts. Um, okay, so core one was really nice and kind of showed this. Core two, unfortunately, when we did the dating, it's a little bit more messed up. There's some disturbance in the core, that you can see the dates are not fitting this kind of nice model. This is the one where I'm not gonna, the geochemistry was fairly similar. But we did do a sort of pilot study of the chemical biomarkers here. And one of the things that we could see in this, is that what we might expect is true, that the further back you go towards the mid-Holocene maximum, the more evidence there is for heavier rainfall. So by about 4,500, 4,000 BP, it's actually, as much as it's still a very wet environment, it's getting drier. And we don't have the data. We didn't get any biomarkers out of the upper part of the core, unfortunately. But this is when, like ENSO, the El Nino Southern Oscillation, is modeled to get more intense in the Pacific. And I think we're kind of seeing that in here. As far as vegetation and everything goes, what this suggests is that these lagoons are not sort of permanent features of the landscape. The vegetation kind of keeps switching back between being sort of submerged, aquatic microbial to terrestrial and back. And we'll look at that more in a minute. Okay, so anyway, those cores were okay, and I think they allowed me to kind of reconstruct that. Yes, we did have some kind of big lagoon here, and after 5,000 BP or so, it starts to infill. North of Mount Mario, which I'm not going to talk about, we can actually see the shoreline being at the base of the hill at 6,000 BP, and then beginning to gradually build outwards as sea level regresses. So, this was an environment that changed a lot during the mid to later Holocene. All right, so those cores were done very quickly and at 10 centimeter levels, but since core one seemed to show that we had this really steady deposition and that this would be a pretty good environmental record, in 2023 I went back and decided to take another core, but to do it at the finest resolution I could get, which with a bucket auger, 1 centimeter is what we were trying for. We didn't achieve that. Somewhere between about 2 and 5 centimeters of depth was what we managed in reality per sample, which turns out to be about 40 years per sample of time, essentially, more or less. So we took this new core, core 23.6, not far from where cores 1 and 2 were taken. I wanted to go back to where core 1 was because it was so nice and intact, but because of land disputes that had arisen, we weren't allowed to go to that area anymore. Okay, so yeah, and that was about 8 hours of constant coring in the bright sunshine, and it was absolutely miserable, to be honest. But we got it done. I got a lot of organic matter out of this core. These are mostly charcoal. I tried dating some short-lived leaves, essentially, which worked out well in core 1. On this one, we had a problem that there was a lot more material that was getting dragged down by the auger, actually, so we ended up with a lot of modern dates on that material. The charcoal, by and large, fits a model that's consistent with what you saw in the other cores. This core seems to go back to about 7,000 BP, although I'm still working on this because I think these are all charcoal dates, so the old wood effect probably plays a role here. We have this kind of steady deposition, again, from about 7,000 BP in this case, all the way down to about 1,700 BP is what the end of the core is modeled as. We do have these two periods where, again, we have some evidence of disturbance that I'm still kind of contemplating. And I just collected these data over the last 2 weeks, so I'm still thinking about what they mean to a certain degree. Unlike all environmental stuff, these are like a bunch of squiggly lines until you really start to look at them. But these are the sort of same indicators I showed you before. Don't worry about the principal component thing. That's just an aggregate of all the information, basically, to look at whether you have really clear patterns in the core that go across different elements. Okay, so what am I seeing in this preliminarily? Well, before about 5,000 BP, we have a core that has really low depositional energy, anoxic conditions, so you don't have a lot of oxygen as these sediments are being deposited. Relatively high but variable calcium relative to titanium, which suggests possibly a lot of microorganisms and things that produce shells like diatoms. And really variable but high strontium and sulfur, which probably indicates brackish water and marine input. So we're looking at a big lagoon, possibly one that dries out and refills periodically, or potentially just has variable input from the ocean relative to terrestrial freshwater coming out of the mountains. But that seems to be what's going on from about 7,000 to 5,000 BP. From about 5,000 to about 3,500 BP, I think we're still looking at something like a lagoon, but the depositional energy is starting to increase. It's starting to infill. And we're starting to see a gradual slight increase in oxygen content, decrease in diatoms and things that are producing this calcium signal, and a real sharp drop off in strontium and sulfur, which suggests that it's getting less brackish, that there's less ocean input into this. From about 3,500 to about 2,500 BP, we have a large increase in depositional energy. We go to really oxic conditions in formation. Calcium, strontium begin to really drop off sharply. And for other reasons, in other cores that were closer to the modern rivers, I could actually hit the paleo river channels where there's gravel deposition and so on. And the dates on top of that are always right around 2,500 BP. So I think up until 2,500 BP, we have like meandering river floodplains, basically, that in this area that are depositing sediment. After that, we go to lower depositional energy, still oxic conditions, but calcium, strontium, other things increase. And, my interpretation, this is basically when the modern sort of seasonal back swamps that characterize the area today stabilized and formed. Obviously, we don't have anything after 1,700 BP because there's no more deposition, essentially. All the sediment's being washed out into the ocean after that. We also have charcoal data for this at relatively high resolution. And what we see, I didn't talk about the charcoal in Core 1, but this is potentially, because it's such a wet environment, there's not a lot of natural burning that occurs here, even in severe ENSO, pardon me, ENSO years. So this is probably human input. And this is something I'm still sort of puzzling with because today people don't really do much burning in the area. They grow sago in swamps. They do a little bit of root horticulture, but they do long fallowing without burning. So when we get these periods of really intense charcoal input, now I should note that some of this does align with modeled increases in ENSO frequency. But, I think that in order to have that amount of burning, what has to happen is sort of the joint effect of humans doing more burning combined with more variable or sometimes drier conditions to to create this kind of signature. So I'm still puzzling through that a little bit. These are really new data that I've just gotten, basically. But, we have this huge spike in burning between about 7,000 and 6,000 BP, right as the lagoons are starting to form. So is it natural burning? No, probably not entirely. Is it people moving onto the coastal flats? That's sort of my working hypothesis. What are they doing? Well, we still don't really know. Unfortunately, we got no pollen or any other preserved indicators out of these cores that might have given us more insight into that. Through the mid-Holocene, you get these sort of spikes of burning periodically and then drop-offs. And the interesting thing is that these spikes in burning seem to correlate with periods when, in the geochemistry, and other indicators, it looks like the lagoons are sort of drying out briefly. So one hypothesis is that people are being forced to intensify other forms of subsistence production, growing yams, taro, things like that, that are more intensive in terms of burning and other things that modify, that would produce this charcoal signature. Again, that's sort of a hypothesis at this point because we don't have direct paleo, we don't have pollen, we don't have starch grains even or anything like that that I could find. So that's still something I'm working with. But again, a lot of this has to do with thinking about like what people are doing, because if you look at modern patterns of subsistence in the area, population density and how intensively people are doing things like burning vegetation do strongly correlate. I'm not going to go through this figure in too much detail, but it has to do with basically the intensity of root horticulture in the reddish areas or areas of higher population density currently. So it suggests that there might be this sort of dynamic pattern of landscape change and how people have to respond to this in terms of these cyclical patterns of population growth that may follow from lagoon formation, followed by sort of lagoon disappearance briefly, and the need to sort of therefore switch to something more intensive in terms of how people are using the landscape. There are also indicators in some of the cores and the charcoal that do suggest that at the end of these burning phases, you're getting into like basically grassland instead of closed forest. And so I think, what we're seeing is this sort of dynamic cyclical pattern of population growth, environmental sort of change, response, the lagoons come back, people switch back to a more lagoon-focused subsistence pattern, and this goes on until the lagoons disappear entirely. There's then this sort of intense period of burning right around 3000 BP. And then it all drops off. And, my working hypothesis is that this is when you get the current pattern of heavily sago-focused subsistence. But, I'll admit there's a lot of inference in there that isn't supported by data currently. And just very briefly, and then I'll stop and give Robin her turn. This is just sort of a working sort of scenario for what's going on in terms of the environment, climate, and what people are actually doing on the ground. And again, not the subject of this talk, but we have almost no archaeological record for New Guinea between 5,000 and 2,000 years ago. Probably in part because if people were living on the coast at this time, their settlements would be buried under like up to 4 meters of sediment, which makes it a little bit hard to find. We do have like some plausible Holocene, mid-Holocene material culture on the north coast of New Guinea. These stone mortars and pestles that are probably mid-Holocene, and there was one found very close to where I did these cores that was described as being found approximately 4 meters under the ground when they were doing some building work. So that seems to check out with what the core suggests about how the landscape built up. I have been excavating a rock shelter there for on and off during this work. And that turns out to actually have a fairly continuous record of occupation going back about 5,000 years. I'm still working through that material as well. But, it suggests, I think, that, the mid-Holocene is a period where we probably have people living here and possibly a lot of people living here. But the logistics of actually uncovering the archaeology of that period are incredibly complicated and challenging because of the degree to which the landscape is built up and formed over time. So the pXRF here is really a pretty quick way to look at these sort of depositional environmental dynamics. Of course, it is part of a bigger project. So it's not just the pXRF, but I think it shows at least how you can use pXRF to get a lot of this kind of geochemical data in a way that would be more expensive and difficult otherwise. And I mean, you could do this in the field. I did it in the lab, but you could just bring a mortar and pestle with you, and that's all you'd really need to do this kind of analysis in the field. But I'm not sure that, like, particularly given how waterlogged the sediments are, that just like cutting a profile and sticking the XRF against it would produce quality results in the way that you get with doing a little bit of sample preparation in this case. So anyway, I'll leave off there and give Robin her turn. So thanks to the organizers and to all the people in New Guinea and elsewhere that have helped with this work and all of the institutional partners. So thank you.
Thank you.
Keelie,
So I
you
believe,
can go on.
yes, I believe it's my turn to introduce Robin, since Mickey is not here with us today. So I have the great pleasure of introducing Dr. Robin Torrence, who is an archaeologist, an anthropologist, an ethnoarchaeologist, a geoscientist. She wears many hats, and who has throughout her career collaborated in the development of new methods for studying trade, stone tool use, and subsistence patterns. Dr. Torrence currently holds a position of a senior fellow after having retired from a salaried position at the Australian Museum in Sydney. Her position now enables her to continue to research on the to do research on the prehistory of Papua New Guinea with projects investigating quarrying, production, use, and exchange of obsidian, and the impact of volcanic disasters on long-term cultural processes, and also on the reconstruction of cross-cultural interactions in Papua New Guinea's colonial history through the analysis of ethnographic materials collections. Dr. Torrence has contributed dozens of articles, journals, books, book chapters. I truly could not list them all. And also field reports ranging in geography from Papua New Guinea to Northeast China to Greece to Eastern Russia. Her contributions span topics of obsidian sourcing, to useware, to archaeobotanical and land use investigations, even things like tattooing tools that have been used in the past. And she has employed several archaeometrical techniques, including Raman and pXRF, which makes her a perfect speaker for today. Speaking of pXRF, her presentation will be on uncovering Indigenous strategies in cross-cultural exchange by unlocking the potential of ethnographic museum collections with pXRF. So, without further ado, Robin, you may share your screen with us.
Oh, uh-oh.
Okay, down on the bottom, it should be
Got
more.
it.
Oh, she's got it.
Now what do I do? Oh, we'll get there.
We'll get there. No
We'll get
worries.
there. Okay. Whoops.
Oh, a little too far.
Okay. We're ready to
Okay.
go.
Perfect.
Sorry, everyone. I haven't done this in a long time. Um, okay, so what we're going to do today is look at some ethnographic material which we studied with pXRF, and Mark was very much part of this project and got me going again, and thanks to him. So I've been interested recently in looking at trying to exploit some of the treasures of museum collections, ethnographic museum collections. This is the Pacific collection, or was the Pacific collection at the Australian Museum. Many people look at these things and they say, oh, all this was ripped off and stolen from all these people. How can you say anything productive about the ethnography? And my take is completely different. Ethnographic museum collections are mainly the product of reciprocal exchange. In other words, people who went in there, it's impossible just rip everything off. Things were gained through the process of exchange. And for exchange to take place, both parties must be satisfied with the transaction. It is not that common that people went in and burned down villages and stole everything. Almost everything in the ethnographic collection comes through peaceful exchange. Now, I've been really interested in the indigenous strategies that went on during this exchange. How did indigenous people, what is the role that they played? And there are a number of different processes that I've looked at and thought about a lot. Attracting interaction with people, encouraging the exchange, profit making and cost cutting, strategic gifting to people to get what you want, asserting identity, largely through decorative means, and withholding material. And what I'm going to be talking about mainly today is attracting interaction and profit making. So we're going to go to the Admiralty Islands in Papua New Guinea. So we're back in Papua New Guinea, but in a slightly different area. And we're going to be looking at obsidian-tipped spears and daggers from the Admiralty Islands. Now, I started studying these when I finished my PhD, where I'd made as you do in your PhD, a whole lot of suggestions about how trade looked like from an archaeological point of view, and suggestions. And I thought, well, maybe I better go look at what trade really does look like instead of just making things up from archaeology. And Margaret Mead had written interesting articles about exchange in the Admiralty Islands, where these spears and daggers come from. So off I went, first to the British Museum and Pitt Rivers and the Field Museum, and did a study on the decoration. Not the decoration has got a lot more work to do, but on particularly the obsidian blades. You can see here that there are daggers, which are short, and spears. Now there's two major kinds of decorations. There's ones that are a sort of clay putty that was put on to attach the staff to the blade, and people engraved designs, and the major designs are frigate birds, which are these incredible, huge birds. The other thing is you can here's the wooden cap, and you have two bits of wood underneath, and you wrap it round with string, and they do these amazing patterns of wrapping and painting. These things were really popular among European collectors in the early 20th century. Here's a page from an auction catalog, and you can see that frigate bird designs. Notice how beautiful the blades are in these early material. So in the early periods, I'm trying to get my little arrow isn't working. Here we go. We have long blades with beautiful retouch, often not without retouch, and not much decoration. As we move into the later periods, you can see how the blades get short and stubby, and there's a lot of really nasty, irregular retouch, but the designs become bigger and more elaborate. People are going from sort of traditional area where everyone knows what everything means to specifically exchanging with outsiders, with Europeans. And they're attracting interaction by making all these beautiful designs, and they're cost cutting in terms of the amount of effort and time and so forth that goes into the obsidian blades. So here's some more examples. Here's the frigate bird, and look at the beautiful long blades from this period. Simpler designs. When you move into the later periods, we start introducing crocodiles and other animals, and we start really carving that collar and lots of wrapping. Look at the size of the blades. These scales are fairly much the same. Teeny weeny little bits of obsidian. And they're interesting ideas. In this period, do you have really specialized producers? They're the only ones who can make these big blades. And so the ownership and control of obsidian might have been restricted, whereas here, you could almost pick up debitage and make these spears with it. So what's going on with the control and production of the obsidian, and can we find ways of looking at that? Another thing that happens is that the daggers become one of the major artifacts. So instead of making a whole spear, you can make one of these little daggers. And you can see, look, crocodiles coming in, they're really big in this period. The frigate bird, you can hardly tell that's what it is anymore. And human faces are really, that happens all over the world in the more recent periods where you get more intense exchange with outsiders. How are we communicating with them? How are we getting these ideas across? Another interesting way that you get attracting things is to make things that look familiar. And these look like axes to us. Now look at the handles, the carved handles. And then you put a piece of obsidian in. Well, obviously you couldn't use this as an axe. One smash and the whole thing would fall apart. But they are familiar with European axes, and they're trying to sell stuff to Europeans. So they're making things they think they might like to have. So here's a from our database that Mark and I put together. The change from originally spears up to a big period of daggers, and one particular collection that went to the Field Museum in 1911. And then in the most recent period, all we have left are daggers. And these were sold a lot to American soldiers during the Second World War. It was a whole new production thing, but not many of them have got into museum collections. Okay, now where does the pXRF come in? Well, it comes into sourcing the obsidian in these blades. And as the question then is, who's controlling the obsidian, the source of obsidian, and the production? We can see all these interesting changes within style and type of artifact. What about looking at the actual sources? So in Papua New Guinea, there are three main source areas for obsidian, the well-known New Britain ones, Ferguson, and the Admiralty Islands. And in the Admiralty Islands, you have the Big Manus area, which has several sources which hardly appear at all anywhere. And then offshore in these little islands, Low Island has two sources, and then there's Pamlin and Pammandian. Interestingly, the earliest source of obsidian used from about 9,000 years ago for a short period was Wekwak. Just remember that. Then Pamlin became quite an important source, and the most recent source is the Umre source. And one of the reasons for that was that source you had to dig deep shafts through tephra to get to, and presumably the earlier periods they're using easier to access material. Now, when I started doing this in 2011 with my Brooker Tracer 3.4, we started working on prehistoric large obsidian valuable artifacts. And we had to kind of think about going into a museum and working with museum people who are going to be pretty worried about having this instrument against their fragile obsidian. So we designed a larger surface on which we could put them, and then we also worked with a tripod. You can see this is early days, we were doing 4 readings of 3 minutes per artifact. Took a while, and lots of standards, and we had a very large number of obsidian source material because this was, to make sure we knew what we were doing. We ended up setting up using a tripod And that, of course, you have to convince the museum people this thing is not going to fall down and smash these fragile artifacts. So you have to work with the curators and the conservation people. These are the places where I went on this first trip. So at the Pitt Rivers Museum in Oxford, one of the conservators had to go through training, radiation training, before we were allowed to bring the pXRF in. And that just shows how wonderful the people in the Pitt Rivers Museum were to support this research. In the British Museum, we had to set up signs, and they set rules about how far away we had to be when we're pushing the button, and no people in the room, and very careful. In Berlin, they assigned us a person to sit with us the whole time to make sure we weren't going to get into any trouble. And also, I think they were interested and wanted to learn. In Basel, we were just in a museum store place. But then the Linden Museum in Stuttgart, a completely different attitude. It was, oh, well, we only have this kind of storeroom with some crates around it. Can you please find a space for yourself and figure out how to work? So there are lots of different attitudes that you run across. But obviously, using a portable machine and so forth, you can find your way on top of an old packing case, or you can do lots of different things. And we had a very successful trip. From that study, we were obviously, the artifacts are in little black squares. I'm having a little trouble with my mouse. There we go. And everything was from the Admiralty Islands. And in fact, everything was from Umliang, and only 2 artifacts from the Wekwak source, which was very, very surprising because, as I say, Wekwak hadn't really been seen since the Pleistocene record. And that was kind of a surprise what was going on. Then Mark took over and got fired up by the study and had a student intern go to the Field Museum with a Brooker 5i. And you can see how times have changed. Only need 30 seconds in one reading, pretty much pour 4 solid standards. And, you know, we didn't, you can just a huge change in what was still successful. And the Field Museum were fantastic. They used our visit, our second visit, when we were looking more at style, as a chance to clean out all the cases, get everything out, make sure everything was there. So it was an extremely useful working relationship. And it was great for me to go back and see this material I'd seen so long ago. So this is the total database, and I'll show you the results in a minute. But we have the early period, I should actually mention the Challenger, 1875, was a scientific expedition that went to the Admiralties, and they thought they were the first white people there to ever see anyone, and they made a collection which is in 3 museums. But in fact, when I went back through my notes and really worked on them, I found we had pre-Challenger material. So by the time the Challenger gets there, the local people knew what they were doing in terms of dealing with outsiders, and already some changes had gone in. And then the other key collection is the Lewis collection, 1911, where the curator from the Field Museum purchased a massive collection from a local dealer. And that there's a lot of interest there to what extent the artifacts were made specifically for trade to Lewis. So when we look again at the results, we see that everything patterns with the Admiralty Islands, and we have Umliang Pamlin now, and a small number of artifacts from Wekwak. And very good discrimination. Materials very clearly, easy to categorize. It's a reasonably large sample, I think. When we look at the obsidian sources through time, we see right at the beginning we had those two little Wekwak. In the next period, not long after the Challenger is 1875, Pamlin has already come into being in use. And during the major trade period, we have Pamlin is expanded to a huge extent, as has Wekwak. And then things, what happens in the 1920s is we start to get plantation labor and alternative sources of income for people. So the artifact trade isn't such a big part of how people could get cash and could get the material goods they want. So what do we think this is telling us? This is looking like that originally the access to obsidian for making these things was controlled or restricted. And if we look back at what Mead writes, she writes about a system in which there are a whole series of different communities, each of which specializes in a particular good. So there are people who make pots, there are people who have particular kinds of baskets, and there are people that have obsidian. And there are specialized traders who move the material between the different places. So in the early period, people are conforming. All the obsidian comes from one island. Both Wekwak and Pamlin Umliang are from Low Island. But as the trade expands, there's white people coming in, offering things. Everyone gets in the action, and they slowly extend the amount of Pamlin. They get more and more in the action. And probably the whole we don't know that the ethnographic system broke down because Mead comes later. But in terms of the tourist production, in terms of the making of the artifacts for sale, the control over access to obsidian or everyone following the rules about who can do what totally break down. And we get different kinds of, as it were, agency of people reacting to these new markets and claiming them and getting on with selling. So the take-home message is that pXRF is one way to expand the potential of working on ethnographic museum collections. And there's obviously millions of stuff you can do. And Mark has started to have or had a look at paints and colorants, which is one thing. And it also enables insights into Indigenous agency within cross-cultural interaction. It's one thing, and there's our wonderful guy. And again, acknowledgments to all the people who helped. Particularly, we need to acknowledge Clay Jaskowski, who is the student who did the pXRF at the Field Museum, and to all the curators who were amazingly welcoming for this new technology that they didn't know much about, and they had to deal with radiation and all those problems that you all recognize, but were very welcoming. And I think the results are absolutely fascinating. So thanks.
Thank you, Robin. Thank you very much for both of you for the illuminating lectures and the complementary ones as well. So it is a time now to ask for any questions from the participants. Any questions, please? Keelie?
Oh, I think Christian has one. So how about we start with him?
Okay.
Poor Christian.
Hi, how are you, Robin? German Archaeological Institute. I have a question for Mark concerning the sample preparation. You said that you were concerned about the water in the samples while analyzing in the field. Have you done actually any tests like how dry the samples needed to be to actually get less variability in your samples? Can you just, I don't know, lay it out for a day in the sun and then it would be dry enough, or do you have to go through an ice dryer or something like that to get really good results?
Yeah. Hi, Christian. Good to see you. Yeah, I don't think you need to go to the extent of like putting in a furnace and then storing in a desiccator or something to ensure, because the water content, I mean, it can be variable, obviously, but, by and large, it's just like a dilution effect, basically. So, it's more an issue if it's like variable between samples. So if you get it to sort of the ballpark, and, I'm not trying to measure down to like half a part per million on any of this stuff. So, all I did was like in New Guinea, I put them out in the sun for like 2 days and they basically turned rock hard. Got them back into the lab and, the most like laborious part of this whole process is like grinding them. Particularly the like siltier samples turned to like concrete. So I could do about 10 of them per day before my hands were like cramping. I don't know. My students that did a lot of the work seemed to have weaker hands than me, so they would only get through about 5. So that's the time-consuming part. But really all you have to do is like put them out in the sun for a couple days, and at that point they're dry enough. Just as long as they're dried all the way through. And if you put them in a lab that has a little more humidity and they absorb a small amount of that, it doesn't make any real substantial difference at the sort of level of precision and accuracy that I'm care about for these. Because it's all relative. It doesn't matter to me whether it's actually 400 or 392 parts per million, as long as I can see that it's more or less, And that was just where, like, if you ran the sample like fully inundated with water, you could get differences of hundreds of parts per million for certain elements just because of the effect of the water on the volume that you're analyzing. Also, like the grinding and homogenizing helped a lot because you do get just variability in the sediment. So, that made a big difference in terms of reproducibility as well. But like going to the length of like pelletizing it was totally overkill. That made no difference in terms of being able to compare samples. So, I think as long as you dry them in the field, they're fine.
Yeah. I would like to ask you, Mark, or to suggest, have you measured susceptibility in this course? Magnetic susceptibility.
Oh, no, I've not done that. That would be something that
That would be
would be
very
useful
interesting,
to do.
actually. Yeah, I recommend you if you can have a
Mhm.
ability, and also the natural radioactivity as a function of depth. It can be used as a chronostratigraphic marker, both of
Mhm.
them, especially
Mhm.
the radioactivity. I have done it in various schools,
Mhm.
and which cover the Holocene, and you can see very nicely the variation within the last 12,000 years.
Okay. Yeah, I'll have to look into trying that. Thank you.
I can send you the reprints.
Okay. Yeah, that'd be great. Thank you.
I did have a question as well for Mark, if that's okay, and I also have one for Robin. Yes, so I was wondering if you saw any sort of like correlation between like maybe calcium strontium and then also the amount of charcoals that you were seeing in those, particularly in that last core, the 23. Just because oftentimes, especially in sediments, usually there will be an uptick in some of those elements relative to carbon input. Yeah.
Mhm. I mean, I guess the short answer is I'm still parsing that out because I literally made these graphs yesterday and finished collecting the data the day before that. Yeah, so I mean the interesting thing here, because yeah, I mean calcium and strontium obviously usually co-vary.
Hmm.
And the interesting thing here is that they don't co-vary all that much.
Oh.
Um, and that's, I think, because you have a very separate input of strontium from seawater.
Mm.
That's not as tied to calcium specifically, just because of the way those fractionate in seawater. So you have periods where you're having a lot of strontium input without the calcium changing as much. And partially I'm using those in tandem to separate out those sources of input. Sorry, I'm still tired. I've lost track of what I was trying to say here.
No worries.
Was there a second part of your question?
No, I think you've covered it.
Okay, you're talking about the charcoal. That was the other
Yes,
part.
about the
Yeah, so
charcoal, yeah.
I'm still looking at that because yeah, I mean obviously the charcoal can input other things into there.
Mhm.
And yeah, I mean that's where like having the loss on ignition data also helps to
Mhm.
parse that out. So I have that on my earlier cores. I haven't yet done the loss on ignition on these yet. And that's done basically with this. You just powder the stuff for the XRF, and then when you're sure you have a good reading, you just weigh it out to the exact amount you need and put it in the furnace. So
Mhm.
it also satisfies the U.S. Department of Agriculture standards for how I have to destroy these samples when I'm done with them. So you put them up to 1,000 degrees Celsius to burn all the carbon out.
Mhm.
But once I have that's another way to help me kind of parse out all those different things. So I haven't done that yet, but that's another thing on the agenda for this summer.
Mhm. And then a kind of follow-up question to that as well is, have you considered doing any like XRD which is like more mineralogical to sort of complement what you're getting from the XRF?
Um, yeah, I mean, it's something I could do. It's always a matter of cost and time.
Of course.
But yeah, I mean, that might be useful in terms of looking at whether you're getting sort of a steady source of sediment input or not, particularly. I'd like to do grain size as well. Oddly enough, like the one instrument in the world that Notre Dame doesn't have is a grain size analyzer. So I haven't done that yet either, but that would be useful as well.
Awesome. Any other questions before I ask another one? Da, da, da. No? Okay. Wait, maybe?
Yeah, I have another one. Am I allowed to Robin, to be honest? I was wondering, you went through quite a few European collections. Did you see any difference in the pattern of what kind of artifacts were collected by different nations? Like, if there's for example, a German governmental agent doing collections against I don't know, an Australian trader who comes in. Was there any, or some British official? Was there any differences in that, or how people reacted to them? Do they give them different artifacts?
Mm. That's really, really good question. I haven't looked at that at all. And for the Monas data, the changes through time, not between different collectors. So the Germans were in the early. Well, we have Bueller later. No, I haven't seen any difference, but I haven't looked at it. I think it would be a really interesting question to go somewhere like broaden it out and say, look at CPIC collections, and then look at the differences between countries. But say, in terms of the monosphere data, no, there's no difference. They're really getting the same thing. They don't seem to. It seems to be more what they're offered rather than what they choose. Yeah.
Thank you.
All right, I'll ask my next one then. For Robin, I was curious if you saw any like if any particular sources related more to like a particular product type. So, for example, you said that there was in the later period more knives and some of these axes that ended up getting made, and I was wondering if there was like a preferential use of a particular type of obsidian for either that or the spears or something like
Yeah.
that.
Well, we don't have enough access to really say anything, but in terms of spears and daggers, no, it's the proportion is about the same in terms of the different ones. And in terms of style, this is something that really needs to be done. And you know, I studied stone because pottery's too hard, all that style and things, really complicated. And I had a good go at the Monas material, and I'll have to go back and work on it again. But yeah, because it's just too many different variables, and I didn't get them right the first time through to see whether there are correlations between style and source. Yeah, I can't answer it yet.
No worries. Thank you. Any other questions from anybody else?
I think so.
I can ask a question.
Yes.
I mean, I was just going to ask the people who are here how many of them or what have been some of their experiences in working on, has anyone else been working on ethnographic museum type material? And what sort of experiences? Because I think there really is a huge treasure chest out there for us. I'm just wondering whether there are other people out there trying to exploit that.
Maybe I can share a story. So what we are currently doing in Germany is looking at all the collections of the missionary orders in Germany, where there are lots. And one of the stories is there that these orders are dying out. They don't really have a lot of young priests coming in. So they are sitting on this massive amount of collections. Some of them are really big, and you have dozens of them throughout Germany. And the challenge is going to be now how to get them integrated either into ethnographic museums in a larger scale ethnographic museums, or get the municipalities to take over these collections. If people have experiences in how this is done in other countries, where you get funding for these kinds of parts, really substantial, talking about tens of thousands of artifacts, collections where these orders they can't or won't continue to curate these. I would be more than happy to hear some ideas about that. And some of them are well, we have 2 here in Bonn where I am, and we are just really thinking about how to get these collection on the one hand online through a digitization process, but how to actually maybe also get them universities interested in research on them, so that they're getting more used, and through the use maybe get a little bit more visibility, and showing the necessity of them not going somewhere into a container and then eventually probably going to be disappearing completely. But this is not cheap. So I would be more than happy to hear any ideas.
Okay, Keelie, what do you think?
Well, I'm not entirely sure how to manage that. So
There is not any question. I think I would say that
I'm not asking for solutions. I was just asking, or maybe if there's interest around. There are collections around which have been largely unexplored, and they are in parts they're large. So yeah.
I mean, I certainly think that there is absolutely value in all of these materials from missionaries being investigated. I know certainly in the US there was a lot of like Catholic missionaries that I think have materials from different Native American groups and things like this, which are certainly wells of knowledge, wells of knowledge, and uh, have many things that could. I think part of the problem is that usually ethnographic museums already have such a backlog of so many, materials in storage and that aren't necessarily being displayed anyways. I would wonder if there would potentially be value in rather than going back to um, like a ethnographic museum that already exists, but rather maybe going to the original communities that produced those things and seeing if there was interest in them either reclaiming those things or producing their own museums, talking about how these were traded to other places. Potentially that could be a better place for them to go rather than into sometimes museums, which also then have the issue of being kind of detached from that original community.
Yeah, I think the Vatican has actually done a very good job with some of the collections that they have and working with community, getting the community over and working with stuff. And some stuff goes back and some stuff doesn't go back, but they set up relationships, and that's the important thing. But of course, the Vatican has a lot more money than many other resources have to do that. But certainly the way forward is working with the communities from which the material came and finding out to what extent they want material back, and then it can be used. And I think also not being too precious about trying to preserve everything forever, because that's not going to happen. So if you give a whole lot back to the community, let them do with it what they want. Yeah.
I think it's also one thing to do is to identify other museums that have maybe relevant collections that where they're already doing this work and working with it, rather than having to reinvent the wheel on every single collection. And there are issues with splitting up collections and everything too, but if there's something in one of these collections and like, oh, that other institution has lots of material from that place, like it might be about creating those networks and seeing what they're already doing relative to that. So.
Mm. And then perhaps if more of us are working on research on these collections and can show the value of the collections in a broader way, that's a problem. Many of this stuff has just been shoved in a corner, and the questions that have been asked of the material are very limited. And there's just so much you can do to learn new things and new perspectives. And working with community will just revolutionize it, because the questions they have are different and interesting. Yeah.
Robin, in terms of your question about working in ethnographic museums or with collections, I don't necessarily work within a collection, but I do work with within ethnographic settlements. And so that's been really, really wonderful. I work on sediments on an ERC project called CAMP, which studies pastoralism and agropastoralism in a lot of different places. But in terms of I think ethnography and working with people in the modern day adds a lot of value and can help us produce a lot of really wonderful models for then interpreting historical or archaeological materials that maybe are more difficult for us to understand. Pastoralism in particular is very difficult to sort of approach from that archaeological perspective. So I also wanted to ask, I guess, both of you about the impact that working with local communities had on your work and on your interpretations and things like this as well, since they tend to have a lot more information than about how things were done in those places.
I think you have to be, I'd have to be very careful about what I said about that, because I certainly have never tried to be an ethnologist with the communities that I work with, or work with. What I've benefited from is just living and working and talking with people from a different culture who have different perspectives. And they ask you questions that you never thought of. And they make you think about things in a different way. And it's often not you get a specific useful fact that you can use in your research, but it's a more generalized way of pushing you out of your comfort zone and making you think about different things that I've benefited from. I don't know about you, Mark. You've done a lot with community in the recent years.
Yeah, I mean, I'm also not a ethnographer by any stretch. But, I mean, going to New Guinea, and I was trained as a European prehistorian originally, so it was a, at times painful experience of adjusting to working in a place where the ethical challenges were more immediate, just dealing with extremely different cultural context, different environment than I'd ever been in. And, I think that part was really important to just like take the 7-hour walk through the jungle with people and watch what they do, how they use stuff in the forest, just learning to ask them like, what is this? Instead of thinking like I knew it was sort of a lesson I had to learn. I mean, the environmental stuff is interesting because when I first was doing this, I had this sort of question because like everyone would always be like, yeah, we know this was like ocean at one point. And I always had this kind of thing of like, are they literally just retelling me the story, the biblical story of the flood? Because it's a very Christian country at this point in some level. Or is there something else that they're pointing to? And I eventually realized that no, they understand the landscape and they're pointing at things like, in some cases not referring to the time period I was working in specifically because there's a lot of Miocene reef and things that are uplifted there. But they'd be like, yeah, there's this giant seashell 14 kilometers inland. Like, obviously, the ocean was here. So learning to just trust, like, okay, lead me to the places where there might be something interesting to look at. And, sometimes that works, sometimes it doesn't. But, just learning to trust, like, these people know the landscape here way better than I do or ever could. And, letting them sort of lead me around and understanding how to not that I view the landscape through their eyes or anything, but just letting them sort of lead the thing was sort of a big change from when I first set foot there, I guess. So that was very important. I think that kind of is similar to what you were saying, Keelie. Yeah, but in the earlier part with museum collections, I mean, I have been doing this other project with these cassowary and human bone daggers that were made widely across New Guinea, looking at how style varies basically as an analog for how we as archaeologists think about it. And that I think more so than the spear dagger data, that's kind of run into issues with what was collected and who collected it and why. But also just the huge variability in what was reported about different collections. Some of them have pretty good information about them. Some have basically none. That's always like a constant challenge with museum collections. I've sort of worked with ceramics a little bit because in the field museum we had ceramics from across the North Coast that have been collected by A.B. Lewis. And I'm trying to look at archaeological ceramics compositionally, using both LAI, CPMS, and pXRF. And, we have this resource where it's like, okay, we have all these pots where we know exactly where they were produced and who made them. So trying to use them essentially as like the reference library for comparing the archaeological ceramics to it. And that's actually been fairly successful in terms of being able to see like, okay, these archaeological ceramics were produced here and these were probably produced there. And also, realizing that in some cases, like the recipes they were using for the clay seem to have been preserved for almost 2,000 years. Like they've been doing it the same way, which is pretty astonishing. That's another example where I haven't done it, but you could in principle go out and go to other museum collections that do this as well. It's not as easy as obsidian where you can point the XRF at it, shoot it, and pretty much know what the source is. And you have to, the pXRF isn't perfect. Like the more high resolution chemical data helps, but there's a destructive sampling that's entailed in doing that. So one of the things I'm working on right now is just looking at how well the pXRF actually does for localizing ceramics relative to the higher resolution data I have. So it's another museum thing, I guess.
Wonderful. There any other questions from the audience or Ioannis?
No, I think we have to stop here and to renew our reunion, when is next? Do you remember? Next colloquium?
The next colloquium is not yet scheduled. We might have to take the break already for the summer since there are many people that are quite
From
busy at
September,
this time.
October, yeah.
Yeah, so we'll probably be resuming again in September, October.
Okay. We thank the speakers and the participants because they stayed up to the last moment. So that implies that all of them, few, but they were particularly specialized. They did this to the subject. They didn't feel fed up. They stayed there, and I hope they have got useful information for their work they're doing. So thank you very much, everybody, for your presence.